Another, the introduction to perfect square. In this topic, we will delve into the concept of perfect squares, which are fundamental in understanding various algebraic techniques and solving quadratic equations. A perfect square is an expression that can be written as the square of a binomial. Recognizing and working with perfect squares is essential for simplifying expression, factoring, and solving equations. Now, at the topic objectives, by the end of the lesson, the learner should be able to Now we are discussing about the objectives of the lesson. Number one is to identify the perfect squares, recognize patterns in perfect squares trinomials, and factor perfect square trinomials, simplify expressions involving perfect squares. We have the references, the Calvi Mathematics Book 3, Discovery Mathematics Book 3, and the forum. And we have the different links that you can access for further references. Allow me to share my screen now. And the perfect squares, the square of a binomial is referred to as the perfect square. In quadratic equations and expressions, using ax plus b squared as an example, we have a totally square equation, that is ax plus b minus 2. An illustration of a perfect squares is as follows, that is 2x plus 3 into 2x plus 3, you square, you get 2x plus 3 squared. X minus 4 squared, x minus 4 squared, you get x minus 4 squared. The characteristics of a perfect square are as follows. A perfect square trinomial is of the form ax plus b squared, which is equal to a squared x squared plus 2abx plus b squared. That is ax plus b squared. A perfect square trinomial can be factored into ax plus b, or ax plus b squared, or ax plus b raised to 2. The square root of a perfect square expression returns the binomial form. How do we identify the perfect squares in a quadratic expression? We check the form, determine if the quadratic expression matches the pattern. A squared x squared plus 2abx plus b squared ax plus 2ax. We secondly check the square root, and that we take the square root of the first and last terms, and if the middle term is twice the product of this product, it is a perfect square. Let's look at the expression for x squared plus 12x plus 9. So for x squared is 2x, or 2 into 2x, that is 2x raised to power 2, and 9 is 3 raised to 2. Middle term, that is 12x, is equal to 2 times 2x times 3. Conclusion, it is a perfect square and can be written as 2x plus 3 and 2 into 2x plus 3 squared, or 2x plus 3 into 2x plus 3. We have the perfect squares versus non-perfect squares. Perfect squares definition. A perfect square is a quadratic expression, can be expressed as ax plus b squared, or ax plus b raised to 2. We have the example x plus 5 squared. This is equals to x squared plus then x plus 25. And we recognize that it can be factored into identical binomials. And perfect square definition, a quadratic expression that non-perfect squares are quadratic expression that cannot be expressed as the square of a binomial. Example, x squared plus 5x plus 6x. It cannot be factored into identical binomials, instead factored into two different binomials or cannot be factored using integers. They have key differences, and one is in the form. Perfect squares take the form a squared x squared plus 2abx plus b squared, and when perfect squares do not follow the perfect square trinomial form. You have factoring. A perfect square can be factored as ax plus b squared, and perfect squares factored into two distinct binomials so remain unfactorable with integers. You have the example comparisons. Perfect square is x squared plus 6x plus 9 is equals to x plus 3 squared. And perfect square x squared plus 5x plus 6 is equals to x plus 2 into x plus 3 squared. You have the exercise. We can factorize the following expression and hence identify x squared minus 6x plus 8, 2x squared plus x minus 6, x squared minus 8x minus 9, 2x squared plus 3x plus 1, 9x squared plus 12x plus 4, x squared plus 12x plus 36, 4x squared plus 12x plus 9, x squared minus 14x plus 49, 16x squared minus 9x plus 1, 5x squared plus 14x minus 3. Yes, that's the end of my presentation.